Thank you. Hello all, and I hope you have a great day, as well as you had a really great night yesterday. And I see that for some of them it was really great, as we have only half of the people here. So today we are going to talk about the regression testing, especially regression testing in OpenTelekom Cloud using the robot framework. Yesterday our colleagues Niels and Alex, they were talking more about the OpenTelekom Cloud, but so you know what OpenTelekom Cloud is offering, but maybe you don't know how we make OpenTelekom Cloud to be really mature, reliable, and also to always provide the best experience. So there are two fundamentals rights about each software now and then. Each software has bugs. It's just they are just not found yet. And the second thing, every time clients never never use the software in the same way like developer is intending to. And because of these two fundamental facts, we use regression testing to avoid any future potential problems in productions, or to find find and search the design or performance or functional flaws in our software. Also, we would like to really make customer feel that software is really reliable and mature. So how we can achieve that? At first, just brief introduction. My name is Vladimir Hasko. Currently, I'm public cloud engineer working in quality assurance team. My main focus is compute, storage, but also other services within OpenTelekom Cloud, and I participate also in ecosystem.
Hi everyone, my name is Kristian Kucerak. I work for T-Systems for 7 years, and the last 2 years I work for OpenTelekom Cloud as public cloud engineer, mostly in quality assurance area with a special focus on container ecosystems like Kubernetes and networking, and also participating in an ecosystem squad.
Okay. So today we would like to start with the initial state where we were 2.5 years ago. Then we will go a bit technical with the robot framework, the usage, some examples. We will also touch the underlying infrastructure below the robot framework, how we have built it. We will mention what we had to face, what were the operational challenges, and how we have addressed them. Then we speak more about benefits from our point of view, and also what are our current limitations. And we will also show you how we present the results of the test cases, how we produce reports and how we produce graphs. And at the end, we would summarize what we have learned during our 2.5 years path, and what we are aiming for in future. At the end, we would like to show you also a live demo. If everything goes well, if no, then we have prepared also a recorded video, but we would rather prefer the live demo. Okay, so as already mentioned yesterday, OpenTelekom Cloud offers a lot of really solid features and services, but all it started in 2016 in March on CEBIT, where OpenTelekom Cloud was announced, and it came with, I would say, really good basis of the services we had already in that time: compute, network, storage, identity, orchestration, and of course images and many others. But as OpenTelekom Cloud was well accepted, it started to grow very very quickly in even exponential way. That was also the main reason why we realized that that manual testing is not sufficient anymore, and it needs really to have a proper automation in place. So our main focus on the automation regression testing is to do the functional testing of end-user APIs. That includes basically the OpenStack APIs and also our proprietary OTC extensions. But that's not the only one scope. Another scope is that we are doing in the regression testing also the full scenario test cases. So we try to simulate the complete customer behavior, what he needs, not only just create server, but to do something with that. At that time, the Tempest was already existing. I don't know, how many of you know what Tempest is? Okay, cool. At least 4, 5, 6 people. The Tempest is a standard or official OpenStack test suite for functional testings. But in OpenTelekom Cloud, we have already faced several challenges. And these challenges, as I already mentioned, the first one was that OpenTelekom Cloud serves, besides the OpenStack native services, also the proprietary ones. Another issue which we had with the Tempest was that we were searching for a solution which would be all in one, which would offer us reporting functionality, which would offer us really easy to use, easy to extend, easy to learn framework. And we were also thinking in the future that we would like to extend our functional testing also by web GUI testing. So not only really API-based, but also simulating the behavior directly in a web console. We were quite a young team at that time, and we really needed a tool which would be easy to learn and easy to adopt for any newcomers. So did we find that? Let's see.
Okay, before we start a short introduction to Robot Framework, I would like to ask a question. How many of you have ever heard about Robot Framework? Okay, not that many. So, in the beginning, let's start with a few quick facts about Robot Framework. It's a generic automation framework mainly used for acceptance testing and acceptance test-driven development. It is widely used by different multinational companies in different domains, just to name a few, Nokia, Cisco, etc. The first idea of this project came from Pekka Clark in 2005, and the same year was developed the first version by Nokia Networks. If I'm not mistaken, 3 years later, it went open source. More information you can find, of course, on the robotframework.org. If you go further, some important information. It is a keyword-driven framework, which means that each test case is represented with a set of keywords or action words. Those keywords are then represented by a set of actions. Those set of actions actually describing what exactly should be tested and in which way. It can be easily extended. That's also one of the main points which we consider as really important. Either native Python, native from Robot Framework point of view, as Robot Framework is written in Python, or by other languages. Which is really cool, it has a good community, which is always good. And currently it runs on Apache 2.0 open source license. So let's take a look at the high-level architecture quickly. At the very top, we have the test data. Test data is actually contains the test cases, including the keywords, with all the data which the test cases and the keywords need. Then the next layer is the robot framework layer. Actually, this is the heart of the system. This parses the test data and then matches the individual keywords to the test libraries. The test libraries contain the test, the keywords and also the instructions, what exactly, in which way it should be the test performed. And then the test library, of course, through the application interface, performs the test, which is, yeah, it depends on the test. In our case, the system under test is the end-user APIs, as it was mentioned by Vladimir. Important fact about this architecture is that the heart of the system, the robot framework, does know nothing about the system which is under test. All the things are defined in the test library.
That makes robot framework really independent of any dependencies or something, some requirements.
That's the fact why it can be used in different domains. Why we use it in with OpenTelekom Cloud. So a quick syntax check. The test data is usually text file. It has .robot extension. Of course, it can be in different formats like HTML. And the basic syntax consists of 4 different sections, normally, usually. The first section is a settings section. This includes the library, which we are going to use within our test case. In our particular case, we load the string library. This library includes string operation keywords. The second section is the variable section. In our particular case, we define a variable with a value world. The keyword section is important in a test case. We can define reusable code. If you would like to compare it with some programming language, we could take them or consider them as methods or functions from other programming languages. And the last, the test cases, the most important. Under test cases, we define exactly what we would like to test. In this particular case, sample test case, that's the name of the test case, which contains one keyword, mylog uppercase keyword, and the result would be a log to console hello world uppercase.
Main advantage is that it's human readable. So even non-technical person can read what the code is about or what the test is about.
The library overview. Robot Framework comes with a solid base of standard libraries. As we've just seen, we've used the string library, one of the standard libraries. Then it can be extended, and there are quite a lot of external libraries. Those are third-party libraries, most of them open source. We personally use extensively the SSH library, where we can connect to the end virtual machine and check the configuration. And for our talk, perhaps the most important are the OTC libraries. What we do with Robot Framework, we define our own keyword libraries and low-level libraries. As you can see, it's not a complete list. Just to have a rough idea, we have individual libraries for our individual services like compute, network, block storage. Those libraries contain keywords which can interact with OTC, with the APIs on OTC. Let's take a look how Robot Framework works. Robot Framework in action. We've prepared two sets of examples. The first set will be a bit more simplified. The second set of examples will be a bit more complex. In each set, we would like to achieve a common goal. So the first set's goal is a test case which checks the API version of a compute service. In this first example, we will use a request library. The request library is a third-party library which contains keywords to interact with HTTP methods, get, post, put, etc. So here we can see that using the request library, what we need in a test case, check API version of compute service. We need a session Then we need to issue the GET request. And then in the end, we need to check the status code. If the HTTP GET request gets a 200, then our test case passes, everything is fine. In the second example, we use our OTC library. The OTC library is actually a subclass of request library where we've done a couple of extensions. In addition, we use the ECS robot library. This is the compute library, which contains keywords related to the compute operations. And the very same test case, check API version of compute service, only one keyword, check ECS API version. We do not need to issue the GET request. We do not need to check the return code. We just issue one keyword, and all the logic is behind, actually, in the test library ECS robot. So just to see the simplification. Let's go to the second set of examples. This is a bit more complex. As you all might know, to interact with the API, we need authenticate ourselves against the API gateway. So in this test case, our main goal is to check an EVS disk, which is a volume disk, a block storage, and check whether the block storage is a SATA type. If it is SATA type, then our test case passes. So what we need with using the upstream request library, first of all, we need a token. For that token, we need to ask the identity endpoint to get a token. First step, the data request, then we create a session, then we issue a post request, then we check the return code, then we set a token, and extracting the X subject token field from the response, and then we set a headers variable into which we put our token. This is a prerequisite, actually, using the request library to be able to issue any request towards OpenTelekom Cloud which needs authentication. And then the actual test case, check EVS disk type. We need a session with the proper endpoint. We need to issue a GET request against the endpoint. We need to check the return code, whether it succeeded. And at the very end, we need to check the volume type property, if it is SATA. If everything goes well, then in the end, we end up with a green test case. That's just fine, but we needed quite a lot of prerequisite steps to achieve this goal. In the second example, we simplified it a bit. We use the OTC library, and you immediately can notice that we do not need to bother with the token creation, as an example. We do not need to bother with the endpoint, which particular endpoint we would like to use. For that, we use service EVS, which is the volume service, automatically defines and uses the proper endpoint. But we still need to issue a GET request, and we still need to check the return code of the API gateway, and in the end, we evaluate whether the volume type is a SATA-based. Here, it looks much better than the previous example, but still we need 4 keywords in a test case to check a simple action, simple parameter of a volume. So let's go to the simplest one. We are still with the same test case, checking the EVS disk type. We are using the OTC library, the base library, which actually is responsible for session creation, token creation. But in addition, we use the EVS robot. This is the volume library, which contains keywords related to volume APIs. So the test case itself looks like one keyword, query EVS disk. This keyword is coming from the EVS robot library. Simply save the response into the resp variable, and the actual evaluation, we just check the property, whether it is SATA. So here we can see actually how from the request library, from the first example, how we simplified the whole test case development process into 2 keywords. And you might also notice that in the query EVS disk, we use disk name. In the API of OpenStack, we need always to use an ID of the disks. But as we developed the query EVS disk keyword, the query EVS disk keyword handles that appropriately. So the test case developer can use either disk name, ID, whatever. The appropriate keyword will handle that properly.
Okay. So you have seen the basic syntax of robot framework, how we use the test cases, how we simplify the work with the OpenTelekom cloud, how to work with the APIs. But you might be also interested in knowing how we have built the infrastructure. So we distinguish two layers of our infrastructure layer and presentation layer. In infrastructure layer, we use jump host or jump server for accessing all the components with our infrastructure. We use GitLab for storing all our code. That means the core library, then all our keywords, defined keywords libraries, then underlying Python module libraries, and also we use also different repository for storing all our test scenarios. So everyone who is working in our QA team is able to reuse of the code and reuse of the scenarios which we have already defined. Then we use InfluxDB for its time series database, and we use it for storing all our test results, metrics, statistics, everything for later use in Grafana. The Ansible playbooks we use for all our infrastructure automations. So for each of the components, we have defined a playbook with which we can always and anytime recreate that component, patch that component, extend that component if it's needed for several purposes, and basically whole our infrastructure is becoming easy to maintain. We have developed also our own supplement API, which is basically API server with some supportive functions for us. For example, one of the examples would be we define in our supplement API the relation between the images and flavors, just to always automatically choose the right image for the specific flavor. The test executors are basically the robot framework instances where we run or execute all the test scenarios. And we use multiple of them to parallelize our robot framework test runs. So, and also to isolate or avoid some conflicts which might be created of parallel runs. And we also use the test executor different for running the different environments. You will see that later. On the presentation layers, we have Jenkins, Grafana, web reports. Jenkins is a job scheduler, so that's exactly the component which schedules all the test runs based on the complexity on hourly or nightly builds, and also it uses some classification for choosing which test should run in which environment, for example. As it has also some reporting and logging functionality, we put it in presentation layer. The Grafana itself is visualizing all our results. There is a really nice feature called Listener in Robot Framework, which basically allows us to send exactly the statistics of the robot framework natively to the InfluxDB and then consumed by Grafana. The web reports is another native function from robot framework, which is really nice, well structured. The statistics of the robot test cases in a web pages. You will see also that later. We have two types of user, DevOps and end user. DevOps are basically us. Who is developing the test cases and developing the underlying libraries. And the end user can be manager, end customer, or operation team who just consume our results and data and then make appropriate actions. From the test case process flow, the test case starts in Jenkins. Jenkins schedules or trigger job, which then calls the wrapper script, and this wrapper script fetches the latest scenarios from the GitLab. Then, with the latest scenarios and also with environment variables and tags which are stored in Jenkins, it pushes this information to the robot framework test VM where the code is being executed, and then the results are being stored on the web reports and on the Grafana where we set, for example, alerts for specific issues or failures which we want to immediately be notified about that. In this example, we have two environments, production and pre-production, but we have more of them. The pre-production environment is basically where any new feature, any extensions, any modification of Open Telecom Cloud starts. After we do all the tests, all the runs, then we get approval for the next step, which is releasing any feature or extensions to the production. And we constantly run the regression testings in both environments and evaluate any deviations from the results. Currently, some basic view on our Open Telecom Cloud modules. As we already mentioned, we have base library, which is taking care of HTTP requests, tokens, authentication, endpoint URL sessions. Then we use libraries like compute, storage, networks, for any actions with APIs, creating, querying, deleting, modifying, resizing, and basically with any resources within these services like instances, disks, routers, subnets, and so on. So basically, you can understand all the OTC modules as the translation layer to the APIs, but very simplified and very easy to use. And then we have a lot of other libraries for other services, for example, for big data, for disaster recovery, for databases. Some of them are fully integrated, some of them partially, and we are still doing ongoing integration, ongoing development of these libraries.
Operational challenges. We've been facing, as I think everyone during our journey, a lot of challenges. This is by far not a complete list, actually. I would like to just point out a couple of things which we think worth mentioning here. First of all, the job scheduling. It was already mentioned by Vladimir. We use Jenkins. Jenkins is actually solving us the job dependencies or dependencies between jobs. We have multiple environments. We have pre-prod, production, hybrid environments. So we have more than 2,000 test cases. We need also classification and categorization of those test cases. So we use the native robot framework tag subsystem. So we tag every single test case with different tags. As an example, we use service types tagging, like compute service, volume service, big data service, whatever. Then we use also tagging based on the environments, against which environment a particular test case should be run. For example, this is particularly important for the hybrid environments, where the hybrid does not have the same set of features as the production one in Germany. Then we also tag based on frequency. The test case which takes couple minutes, couple seconds, can run regularly every hour. The test case which takes, I don't know, half an hour, then those test cases run once a day. Already mentioned partially the infrastructure maintenance. Every single component needs, from time to time, some patching, some maintenance. In case something goes wrong, something breaks, we need to rebuild. And also we need sometimes extend, scale out. For all these purposes, all these actions are actually, we use Ansible playbooks. So this can be easily triggered in case that it's needed. Resource quota limits, very important point. Every single tenant in which we use, in which we perform regression testing has a certain set of limits for each individual object. Sometimes it happens that the test case leaves some orphan objects in a tenant for whatever reasons. Either it is a bug in a test case itself or some instability of the system, whatever reasons. We need to take really seriously the cleanup methods within the test cases, and we really emphasize our test case developers to use proper cleanup. For that purpose, the robot framework has special sections called suite teardown and test teardown. Those are special sections in the test cases which are executed even if a test case fails or was interrupted, for example, manually or for whatever reason. So this way we can ensure that the resources which have been created during the test are properly deleted after the test. For the alerting, as we all know, every system needs some kind of alerting. Who would be looking at the graphs and dashboards every day? So we need to be informed. For that we have two levels of alerting. The first level is on Jenkins. Jenkins alerts us in case we have some issues with the jobs. And the second level is on Grafana. Grafana alerts us in case of some anomalies with the data, what it gets. I don't know. Too many test cases failed for a given time frame, for example, or can be something else. Benefits and limitations. Again, this is not a complete list, just a few of them to mention. If I was to ask to mention only one benefit, which I personally see as the really most valuable in this approach, I would say the simplicity. Easy maintenance. We are in a team in which not every single member develops the libraries. Some of the members in the QA develops only the test cases. And for those people, having a proper test library and prepared keywords, the development of the test case is really easy, as you've just seen. You just need to know which keywords are available and which parameters the keyword can consume and what is the return code. Based on that, they don't need really a developer experience or knowledge, but they still can prepare complex scenarios, test case scenarios. On the other hand, exactly this fact brings us to one of the major limitations with our system. We develop our own libraries. We have a limited number of people within the team, so we sometimes have some backlog in development. As always, the more code we have, the more we need for maintenance, bug fixing, etc. So this we also see as a kind of limitation. Robot Framework has a couple of cool features like merging reports. We have multiple environments, we run multiple jobs, but we would like to see one consolidated report. For that, we use merging reports. The merging reports feature can merge all those reports into one HTML report, and yeah, we have one consolidated report where we see all environments. Auto documentation feature, actually we are in the middle of implementing this, but this can automatically create documentation out of the test libraries and also the test cases, so we do not need to write them manually. Listener support is a feature which we use for sending metrics to Grafana from the Robot Framework test cases. Of course, it's open source, it's cool, and yeah, the parallelization we've mentioned. Currently, we use Jenkins for that, even though there is a project called PABOT, Parallel Robot Execution. By nature, robot does serialization. Every test case, just first test case finishes, then it starts the second one. PABOT can solve this issue, but here we would still need some kind of evaluation, and we might improve our work in this area. Let's continue with reporting.
Okay, so we went through the syntax, we went through the benefits, we went through the infrastructure. What to do with the data which we gather? We have a lot of statistics, a lot of reports. And we use basically two ways. The one way is used to web reports which are natively supported by Robot Framework. As Kristian already mentioned, one of the nice features, especially for management, is to see the really general view, the current state of all behaviors, of all environments. In this example, we have production, pre-production, then especially availability zone 3 in production, which was, this is some historical view, but it was when we were extending third availability zone, we wanted to see only exactly the reports just from this availability zone, how it is behaving. And then also some reports from hybrid. Good view, good, very quick benefit of this to have really brief idea where we have some gaps, where everything is running well. Then we can have a slightly deeper level view of the reports, which are aggregated by tags or by service types. Service types are, in our case, are basically represented by suites, and suites are basically directories where you run the tests. So if your robot framework is going through the all tests, because you don't need to run just one test case, you can run the whole directory, then a robot automatically categorize the directories are different suites. And additionally, you use tags for whatever reason you need. So if you want to distinguish tests by the release, that if we have quarterly releases, then you would like to see the test results by this quarter release, or you want to see only the hourly runs, or hourly tests, or nightly tests, or you want to see only, for example, stable tests and not devel tests, and so on, so on. So this is really nice as a view to see specific part of the test case or of the test suite. And the most beneficial, at least for us, report is detailed report, which gives you really step-by-step report of each test case, of each keyword which has been executed, with information about the time, information, more details about what were the variables used, what were the data actually in this keyword, and even you see the errors. You see exactly where the test case has failed, what was the issue, and based on different log level, like info, debug, trace, you can end up to the HTTP requests directly in the report. So you can even see the post request with post data with the payload, what exactly you were pushing to the API gateway, and what do you get as back, whether the response code was fine or whether there were some issue directly in the syntax of the JSON which you are preparing for the API request. This is really nice. The problem with that immediately comes that if you enable debug mode, you can even reveal sensitive information, for example, your token. So if you don't want to do that, never publish the debug reports to public, hey? To some web page which is available from public. That's just one warning you need to be aware of. From the Grafana point of view, we visualize data, and our results we can use basically for anything. For example, in this case, we are just calculating SLA of the test case, and the test case is, for example, deployment of ECS, ECS is a server, deployment of the servers in the 2 different availability zones, which is running every, let's say, 3 or 5 minutes permanently, and we see calculating based on the past and failed tests, we calculate the availability of the availability zone, whether it is behaving normally or not. Then we can have, for example, result of the specific test case, and we can measure the duration of the test. This is also important. When you, for example, even deploying the server and your deployment increases from 30 seconds to 2 minutes, then you clearly know that there is some degradation in performance on the specific availability zone, and then you should evaluate whether this is a trend, whether something has happened in time. For example, in the last 30 days, your duration increased by, I don't know, 1.5 minutes. Then definitely you can again push this back to the operation and start investigation what has happened, whether they added some or whether some of the hypervisors have no proper health status, or whether there was implementing some patch which degraded the performance. And you can also aggregate the view of all environments and have a table statistics, again graph statistics of all runs. Basically in Grafana you can do whatever you want with that. So as already mentioned, we are working in QA 2.5 years, and during that time we experienced a lot of issues, and we set up some best practices. We set up something we try to achieve every day, and basically what Kristian has already mentioned, the cleanup is one of the most important things. If you don't do proper cleanup, you really quickly reach up the quota, and then all your test cases are just broken or just not running. There are several things that you can do this, not only on the test case level, but also on the overall level. For example, from Jenkins job, so you can every day or every night you can run some cleanup script which completely clean your environment, so you avoid any orphaned resources. Another thing which is very important, you will always have mixed team. You will never have in one QA 10 or 15 developers. You have also the people who are really good testers but not good developers. For them, you should always prepare the environment in the way that they can really easy to use. That means, like Kristian has mentioned, develop the libraries for them and make the usage of this library easy for them. So rather than putting the programming logic directly in the test case, move this to the library and only provides the necessary parameters and the keywords for the testers, and they can easily build up the test scenarios. Another benefit of this is that you will keep test cases simple, and anyone who will come after you or who will join the team will be able to read these test scenarios.
And just to mention, in case something changes in the platform, your test cases remain the same. You don't need to change the test cases. You just need to adjust the test case documentation or the keyword definition.
So it brings the standardization. If you use one test keyword from the library, you only need to change the library and not to change the hundreds of tests you have already developed. Again, mentioned, as your infrastructure is growing because you are adapting more features, more services, more functions, more extensions, then even your test environment will grow. So automate everywhere where it is possible, whether you do it with Ansible, Terraform, or any other tool, but always think not to do anything manually, just always automate. Test case always should be independent. That means that you never want to pre-build some prerequisites which will be consumed by different test scenarios. Rather, build all the environment within the test case. If you need to deploy the server, you need also the router, you need also the subnet, you need also the security group. Build it within this test case. You make, with this approach, you always have your tests independent, and you will never face the issue with the dependencies, with the quite hard troubleshooting, what has failed where and why this is failed. And the last but not least, if possible, use, or not if possible, rather always use the dynamic resource names. That means if you are creating the resources, add, for example, random ID to that, and you will avoid, again, the conflicts. Because if you have multiple hundreds of tests where they are using the same resource name, you may end up that one test case fails and don't, for example, properly clean up itself. Another test case will be cleaning the resource from the previous test case and not his own. Yeah, so that's only one example, but always is better to use dynamic names rather than static ones.
Every object should be unique.
Okay, and as already mentioned, in our future plans, we have a we currently our OTC robot framework environment is not published. It's not on a GitHub. It's on our company's internal GitLab, but we are aiming for releasing it, of course, for free to GitHub. The next step is that we would like to also integrate OpenStack SDK, which is because until now we were mostly developing our own libraries. But OpenStack SDK is already offering a lot of really nice features where we don't need to double our work. And this approach is already ongoing, and we are doing already some proof of concept. I have 2 slides about that. We still need to continue on our keyword library development because Open Telecom Cloud is growing and growing. And basically, with that, we need to achieve that all our testers are always able to still develop all the test scenarios for the new features, new improvements. Cleanup has been already mentioned. We're still doing the improvements also there. Auto documentation has been mentioned. I would, just to quickly get to the live demo, I would mention, just very quickly brief, this is a view of the integration of OpenStack SDK with the OpenStack library, and a very brief example of having a deploy three keywords, deploy, query, and delete. This is already integrated as a proof of concept. Is this working? And quick view of the keywords library below. So for example, for the method create server, you can see that server is already calling directly the OpenStack SDK. So even the integration of the OpenStack SDK is quite simple. Only what we need to do is add more, some supporting functions, which allows you to use IDs or names and some other formatting stuff, but it's already working. So we will continue to work with that.
Yeah, as we are running out of time, let's jump to the demo session.
So, okay, here we will at first show you a very simple example of server deployment. So demo short robot. As already mentioned by Kristian, is that font okay for all of you? Okay. We have section settings. Section settings, besides the libraries, it contains also some other things like documentation, tagging, and setup and tear down suites. It is exactly what he has mentioned, has a really benefit when you want to do further cleanup. Then we have a section of variables where we set up the dynamic variables like you see here, but also some static. When we, in this example, we want to deploy S2 flavor with CentOS image. Then we have a keyword. Here we have exactly the keyword which will help us to deploy all the network necessary stuff like router, subnet, security group, and so on. We have a tear down suite where we make sure that everything is deleted even if some of the test has failed. So this ensures that the delete ECS, that the server is always deleted, and the deinitialized network always clean up all the network stuff. Here is the test case itself. First thing, test case, create ECS with custom flavor and the image ID. We use a simple keyword, create ECS native. We use a name for the server, flavor, and image. As you can see here, if you would do this same with the API, then you would need to specify ID of the flavor, ID of the image. We don't need to do this. Our create ECS native keyword is already taking off there. So it finds that image name and query the IDs. Everything is happening directly in the library.
In fact, the absolute minimum is just a server name to define. All the other values have some kind of default values,
which can be dynamically chosen based on the environment when you are testing that. Wait for ECS is a simple keyword which is waiting until the ECS is available. In the query, we are doing some only the relevant keyword is query ECS. This is from our library. All others are just for logging functions or for making some variables like server ID. And in delete ECS, we again just call the delete ECS native. This is our keyword, and wait until the ECS has been deleted. So now we run it. And at the same time, I can log in, and we can see. So we go to Elastic Cloud Server. Is it also font is okay for you? Okay. So now create ECS is ongoing. So we should refresh. Hop. Yeah. Server is already being created. It is D4CFDE something, and when it reaches its availability or more running state, then we will get this information here also in the robot test case, as it is providing some log functions. Okay, it's still creating. Based on that, you can also evaluate, based on the duration of the test case, you can evaluate whether the platform is behaving normally or abnormally. If it takes more than 2-3 minutes, then yeah, there is something. Okay, we have a running. At the same time, we have already another part of the test case, which is a query, and we see some query data like the name, the ID, flavor status, image ID, availability zone where it has been created. And the last keyword is delete ECS, which is already deleting the server. And when you look, the server is gone already. So that was the very simple one.
Perhaps in the meanwhile, you can, I think you have also the log files and the report files you can show. And in the remaining 3 minutes, we can jump to the question sections, if any of you have any questions. Yeah?
Is there any hierarchy of tests that maybe the creation of a tenant that fails, no subsequent tests?
Yeah, sure. There are, as you've seen, there are special sections in the test case setup and tear down sections. The setup section is a section which is executed or performed before any test starts. So in case that the test case has some kind of dependencies, like in our case, creating an ECS needs a network object, we define it in a setup section, create the router, subnet, network, and then we execute our test cases, and the tear down section, which is always executed after each test case has finished, or even in case that some test case fails, we can delete those prerequisites. So there is an option for that.
As you can see, just one note, as you can see, this is the log from directly produced by the robot. It's a really nice, deep level. We didn't even enable debug here, but if you enable, you would really see all the posts, all the data which is really in deep level.
When will you publish your work on GitHub?
We hope for 2 months period of publishing. Basically, everything is already ready. We need just go through and clean up if there is some rubbish.
Yeah, we need to find a time for that.
That's always the time, only the time issue.
So I'm sorry to be a spoiler here. Just one more question, and then we have to move on to the next talk.
Mm-hmm.
How much time does it take you to onboard a new member? That is,
So how much time does it take you to onboard a new member to your QA team, which is not a developer for this framework? So in
okay,
average.
when he never saw the robot framework, I would say within 1 month we are able to set up him that he's already doing the test case development, because we have a really huge amount of tests which are already produced. So only what he needs to understand the syntax, and he needs to read already created test cases, and then he can support and collaborate.
We've also prepared trainings, training materials, and also sessions for newcomers, actually. So we are able to, I don't know, have a half-day session for newcomers related to the robot framework and the infrastructure.
What is fun is that you don't really need developer. You need normal guy who just understands IT, and that's something completely sufficient. It's just you need just some enthusiasm. And what you should take away from this robot framework session, just take really the regression testing seriously, because it really helps you to avoid disasters in production or in some customer environments. And try the robot framework, it's fun. So thank you.
Thank you very much.